Resets play an important role in synchronized FPGA systems. Every FPGA engineer needs to be familiar with resets, but there are also some challenges to using them correctly. In this interview, we will be talking to DornerWorks FPGA engineer Carl Ribbing. Carl, what can you tell me about using resets in your FPGA design?
Yeah, so we have asynchronous resets, which are not associated with any particular clock domain. They could be coming from like a CPU, for example, but they're going to reset your logic back to a known state. For RTG4, it's generally a bad idea to use an asynchronous reset in the design just because the routing resources is limited with those asynchronous resets, and you could end up with a design that's not able to be routed onto the part. So for RTG4, you definitely want to be using synchronous resets as much as possible and limit the fan out of the asynchronous reset. So you want to send it through a synchronizer. So synchronous resets are essentially, we just take a synchronizing block, which I can talk about in just a second, to generate that synchronous reset. And what this does is it associates that reset with a particular clock. And so you'll have a synchronous reset for each clock domain that's used in your design. And the best practice for that is to assert a reset asynchronously and then deassert it synchronously. And the way you do that is with a shift register, and you reset the shift register to the asserted level asynchronously, and then you can shift in the deasserted value through that shift register and assign your the last bit of that shift register as your reset. And that'll give you a good synchronous reset for the rest of your design.
What do I need to be aware of before I start using resets in my FPGA design?
Resets are usually really high fan out, and so you need to be really careful with that because you could end up consuming a lot of your routing resources in the FPGA. So it's not recommended to just reset everything if you can. Take advantage of the FPGA. Most modern FPGAs all come up in a known state. In the case of RTG4, and really most FPGAs, they all come up, all the flip-flops, all the LUTs, all the block RAM come up when you power it up as 0. So take advantage of that. Be very mindful in your logic on what you actually tie to a reset. Anything that's not reset to 0, you're going to have part of your reset. But generally, resets should be used for control logic and state machines. Your data path really doesn't need to be part of your reset. And you can be sure that your design is handling flushing of that data path by running simulations and making sure, when your simulation starts, all your data path signals will probably be X because they're not initialized because the data path is not part of the reset. And your design should be able to flush those X's out naturally just with good design practice. So if you're very tactical with your resets, you can reduce the fan out of those resets, and you can save the really valuable routing resources for the nets that actually really matter, because your resets, they happen, maybe a few times during normal operation, if that. They may not ever happen. So don't waste all of your routing resources on a reset.